In this presentation, we're going to look at some key terminology used in graph theory. So let's start off with the basics. Well, first off, we have a vertex, or as we will pluralize it, vertices. A vertex is a location, or in other words, a stationary point on a graph. So in this particular example, v1, v2, v3, v4, and v5 are vertices. An edge is one of these lines that connects two vertices, and here they're depicted in red lines. For example, E1 is an edge. Incidence describes the fact that an edge and a vertex are connected to each other. For example, V1 is connected by E1. So in this particular case, we would say that V1 and E1 are incident. Adjacency describes two vertices that are connected by an edge. So we actually have quite a few examples here of adjacency. V1 and V5 are adjacent, V1 and V2 are adjacent, V2 and V3 are adjacent, V3 and V4 are adjacent. Now we're going to look at paths. A path describes a sequence of vertices that are used to connect to a sequence of edges that are used to connect two vertices. So for argument's sake, suppose we're using V1 and V4 as our vertices for this example. One possible path would be V1 to V2 and then V2 to V4. Another possible path would be V1 to V5 and then up to V4. So it's a slightly different idea from an edge in that we can describe multiple edges to describe a connection between two vertices. A simple graph, I'm just going to talk about that first. A simple graph is when we have one edge between each pair of vertices. So as we have it there now, just bear with me a second, I'm going to get rid of those blue lines. As we have it now, this is a simple graph because between each pair of vertices there is only one edge. So as it stands now, simple. Suppose I was to add another edge between two pairs of vertices. So let's say, for argument's sake, V1 and V2. I was to add edge E7. Now in this case, the graph is not simple because we have two parallel edges. This one and that one. A loop describes an edge that starts and ends with the same vertex. So for example, we have a loop here. E1 connects V1 back to V1. So we describe that as a loop. Now another important matter is a connected graph. A connected graph means that there's a path between any two given vertices. As it stands now, there's no path between V1 or V4 or V5. You can only go to V2 or V3. So what a connected graph describes a situation where there is a edge between there's enough edges so that there's a path between any two pair of vertices. So this graph is not connected right now. If I was to add in an edge here, E5, let's say, this is now a connected graph. Lastly, an isolated vertex is a vertex where there is no edges incident upon that vertex. So for argument's sake, we have V6 here. There are no edges. This vertex is described as an isolated vertex. And that concludes